Hi, this is Allison from East Cobb Tutoring Center, and we are going to see how a binomial series can help us expand a polynomial. So let's start with a formula. It is a plus b to the k power. So this is our binomial where we have two terms, a and b, and it is going to be equal to the sum from n equals 0 to k. And we've got this thing, k, choose n. We'll talk about that in a minute. And then a to the k minus n, and b to the n. This formula looks like a beast, but really it's just a pattern. We're going to talk about what it means, and then we are going to plug in a couple of things and try it out. So first, let's talk about this thing right there. That is the same thing as saying if you have k things and we want to find a number of combinations taken n at a time. So it's combinations. On your calculator, you might recognize this thing, NCR, meaning n things taken r at a time, number of combinations. So if I were to give you, let's say 6, 2, it would be the number of combinations that we could do if we had 6 things taken 2 at a time. So let's check out that number. It is 15. So here we go. All right, so next thing we're going to do is talk about the a to the k minus n. There it is, and the b to the n. These are going to be variables. So, if we started with x, then this would be x. If we had a y, then this would be y. And the exponents here always add up to the exponent that you started with. All right, so let me clear a little space on the whiteboard, and I will show you an example problem. All righty. So what we're going to do is we are going to expand x plus y to the 4th power using this binomial series expansion. So here's what the formula is going to look like, starting with 0, going to 4. 4 things chosen n at a time. X to the 4 minus n power, and then y to the n power. Alrighty. Okay, so I'm going to, I think I'll leave a blank here, a little space, to kind of prove my point. We're going to start with x to the 4th, and then y to the 0. The next one is going to be x cubed and y to the 1st. You'll notice the exponents are adding up to 4 each time. Then we're going to have x squared and y squared. The blanks that I'm leaving are for the coefficients that we'll calculate in just a minute. Then I'm going to have, running out of space, I'll put it down here, x and then y cubed, and then finally just y to the 4th. Okay, so the numbers that we are going to put in each of these spaces right here are going to be what we get when we calculate the combinations. 4 choose 0, or over here this is going to be 4 choose 1, each time going up all the way till we get to the end where we're going to be doing 4 choose 4. That's the number of combinations that can be made with 4 things chosen 4 at a time. All right, so let me clear out the blanks I just made. Oh, it's taking a long time. Maybe I'll use the eraser instead. Here we go. All right, so let's fill those numbers in. Now you can find these on your calculator. This one I don't have memorized, so I'm going to have to think about it. 1, 2, 3, 4 things chosen 2 at a time. I think it's a 6. Let's see. Yep, it's 6. Okay, so this would be my final answer. Now, if you're thinking to yourself, how can you have those numbers memorized? I'm going to show you a trick. This is called Pascal's triangle. And the coefficients in the binomial series expansion are the same as the coefficients from Pascal's triangle. There we go. So what I'm doing is just adding, oops, that's the 6, that's the one I couldn't remember, the 4 and the 1. So let me show you the method here. You'll notice that the outside numbers are always a 1, and the number underneath is generated by adding the ones above it. So this 4 is made with the 1 and the 3, the 6 is made from the 3 and the 3. So the row of the triangle goes like this, 0, 1, 2, 3, 4. So we started with something that was to the 4th power. It was x plus y to the 4th. That's what we started with. So we could just go down to the 4th power row on Pascal's triangle, and those are the coefficients. It's a little bit easier than calculating the combinations each time.